Hello guys, welcome back to my channel. I am Pooja and today I am going to explain about DRC. In previous video, I have discussed about the LVS, how it will work and all the things, how errors will be created and how can we solve order of the fixing the LVS and what is the process, those 3 steps and extra, etc. So if you want, you can go and check out the video. It will be given in description. I will give the link in description. Today I am going to discuss about the DRC. DRC, it is a design rule check. Mainly we are doing DRC and LVS. Why it's needed? What is the point of this? Why it's needed means normally we want chip which is a robust and should work properly and performance should be perfect. So to check this reliability, is it work or not? We also don't know because fabrication will happen. After fabrication, we want maximum yield. To increase the maximum yield, we go for the DRC and LVS, which gives us reliability. So DRC is a design rule check, and it will occur. Sorry, DRC. Actually, DRC is design rule check which follows the DRM rule. Whatever DRM says, it will follow all the things. Like DRM is a design rule manual. DRC mainly checks for the geometrical correctness. Another sentence for DRC is it check for the geometrical correctness. Physically, whatever width, how much should be width, how much should be length, all the things will decide by DRM rule, and this will all the things will happen geometrically. How abutment and all the things will come under DRC only. If something mismatches like spacing, width, spacing, width, area, these all things and explicitity. So it will check for metal, how much width of the metal, and via poly OD width, length, not length, width, spacing, area, and mainly DRC also checks for latch up antenna. These also come under DRC only, but we will discuss about latch up in detail. And N-well gradient density. Density is the one of the main thing. Density error. It will check for the density of metal, density of base layers, all the layers. Means density should be minimum something 25% and maximum something 80%. It should, whatever written in the DRM rule, we should maintain that density according to the DRM rule. If want, it will give the errors. And the DRM rule varies from one node to another node. Like 40 nano having some different rules and 7 nano is having some different rules. So every node is having some different rules. And it also checks for the enclosure. Like one metal is here and another metal is here. So how much spacing should be in between this enclosure, all the things it will check for the metal means chip reliability and give the errors. It is a kind of DRC. Like reliable should matters. Reliability, for reliability and robust purpose, we go for the DRC. We can't say that like if DRC will be clean or chip will work. We can't say that. It totally depends on the fabrication. It's our assumption that if we do these things, our chip will work fine and work robust, and it will go up to many days. And in DRC only there is another thing, DFM. DFM is a design for manufacturability. I have given these things overview. Just I am describing little more what exactly how it will be. So DFM is also a kind of DRC where DFM gives some more uh, reliability and robust. How means there is a no difference between DRC and DFM. Just the thing is DFM, we can say that we increase the number of yields more. Yield means number of working chip by total number of manufactured chip. Out of this total number of manufactured chip, how much working chip is there? So this we call it as a yield. And DFM is an extended version of the DRC. Why we say that DRC is extended? DFM is the extended version of DRC means actually it is same, but we will take some. If the DRC is having something 0.07 width, or we should maintain something around 0.11 space. DFM will like take around 0.11 for width and something 0.14 for space. Like we are make sure that we are providing more reliability to not short, should not shorts will occur, should not occur any opens, those things we are taking care. So it totally depends on the how we will manufacture. Someone go for the DFM, someone go for the DRC. It is all about the cost. If will DFM will cost more than DRC. Like if we do the DFM, obviously area will increase. Due to the area will increase, the fabrication process and have and more things, those things will take cost high. And sometimes yield may increase or decrease. It totally depends on how we are doing that. If really yield will increase, we go for the DFM. Otherwise we will go for the only DRC. Now you know what DRC will do and all. Like another thing in DRC and DFM, it never responsible for the electrically. It it won't see for any electrical correctness and functionality. Just the chip. DRC clean means just our block is having a correct space width and all, because the function we want the function as intended, so we want that reliability. That's why we checking for the DRC. And another thing, we can't say that if DRC is clean we can't like LVS no matter, or LVS is clean DRC is no matter. We should ensure that DRC and LVS both should be clean. And also we have to take care of all the components, how exactly we are placing and doing the things. So we look for that also. And I will tell about the DRC error fixing order, how it will be. DRC error fixing order. Normally DRC error fixing order, we start from the base layer, because first we should check for the base layers, because if we go directly for the metal and vias, all the things, if base layer is not clean, if you directly go for the metals and vias also, it will waste, because after connection and all we can't fix the base layers. After all, we have to remove all the things and do the we should manage all the things another time, or we should do new design. That's why we first go for the base layers. After placement, before routing, we will first ensure that base layers are clean. After that only we go for the metal connection and metal routing. So in base layer, what we check for means base density violation. Like I said, no, uh, density should be from something around 25% to 70%. It is minimum and this is maximum. It should be around that, whatever DRM rule says. Because for the CMP process, in chemical mechanical, CMP means chemical mechanical planarization, which really when we do some polishing, chemical and mechanical polishing, what happens, sometime it will bend in the empty area. So we don't want that, so we have to balance the minimum density. For that we go for the minimum density, and it ensures that reliability and performance. Yield will increase, and gradient density is same only. Next, latch up, NVL, NP, these are the base layers. These should be correct spacing with the correct width, space, and all the things. It should be managed correctly. These are about base layers. Which are those means? Latch up means adding the tap cell or connection of the body, NVL, then NP, PP, poly, OD. Okay, these are the base layers. Now after completion of base layers, we go for the metal, mainly for the metal vias. In the metal DRC, we check for the metal width, metal space, and obviously metal density. It should also follow the metal density. And sometime in some node, in lower blocks we don't do density, in higher blocks only we do density. If it is minimum, it's fine, because maximum will be problem. Minimum is fine, because in higher blocks they will add some filler cells which will uniform the density. So we don't care much about density when we do the layout, but density should be concern of the DRC. And when we come to the VIA is about same thing, space between one VIA to another VIA, space between VIA and metal, all those things. So these all about the DRC fixing order. First we have to take care of DRC base layers, then we go for the metal vias, because if once we connect or routing will happen, then we can't change the base layer. So placement, after placement, we should do once DRC check, and after cleaning the base layer, then only we have to check for the metal and vias. And this is all about the DRC. It is all about DRC is all about geometrical correctness. and DFM is a extended version of the DRC, so I took this topic also in this only. If you want the LVS also, it is covered in already in last topic. You can go through it. Link will be in description. And thank you for the watching this video. If you have any query, you can ask and share the video to your friends. Like, comment, and please subscribe my channel. Thank you for watching.